Okay,
Hey, Miss Peters.
we need to start on 7.1.
Miss Peters.
What?
If I got an A on the math test corrections, how much would that raise my
I don't know,
grade?
we'll get it later. Okay, 7.1. Today we are focusing on graphing, Olivia sit. We are focusing on graphing exponential functions. Okay? Exponential growth functions. So everything we do today is growth. Okay? Tomorrow we'll talk about exponential decay, but today we're talking about growth. No, put them in that box, put that box back there behind you. Okay, so exponential growth. Where are you going, Caleb? Is that your seat? Caleb, is that Caleb?
Get my pencil, Miss Peters.
Okay, exponential function, here's the deal. An exponential function, the parent function is in the form y equals a times b to the x power, where a cannot be 0. Okay, y equals a times b to the x power. A has to be greater than 0, and b has to be greater than 1. Then the function y equals a times b to the x is an exponential growth function. B is the growth factor. Okay? So your parent function looks like this. In simplest form, it would be f of x equals b to the x, where 0, 1, it crosses through. Okay? Your domain on this is all real numbers. The range is y is greater than 0. It's not going to cross over that x-axis and go into negatives. Okay? Also, your asymptote, okay, your asymptote is the line. We've talked about asymptotes before. Okay, your asymptote is the x-axis. Axis.
Miss Peters, I lost my pencil.
Oh my gosh, guys, you're so immature.
Guys, stop and pay attention. Olivia, put the computer away. Olivia, put the computer away. You're not gonna have a teacher. Focus.
I'm being such a girl.
You guys good back there? You ready?
They're never smart.
Okay, so we then are going to take a look at several different types of graphs. Okay, y equals to the x. It wants us to graph y equals to the x. What do you think we need to do to graph this?
Get X values.
To what?
Get X values?
Get x values, is that what you said?
Yeah. Plug
Yes.
numbers in.
We're going to plug numbers into x. I suggest on your homework plugging in -1, -2, -1, 0, 1, and 2 always. Okay? Plug those numbers in. Now, when I plug this in, if I plug -2 in, I get 2 to the -2. What do you have to do with that?
Flip the exponent.
Flip it.
So that
What are
would
you
be
doing?
1 over 2. So it would be the square root of 2.
So it's 1 over 2 squared, which equals what?
Wait, 1 over 4.
1/4.
1/4.
Okay, 1/4. Then you have y equals 2 to the -1. What happens there?
1/2.
1 over 2 to the first, which is 1/2. Guys, focus. Then you have y equals 2 to the 0. Anything to the 0 is?
1.
Good. Then you have y equals 2 to the first, which is?
2.
And then you have y equals
4.
2 squared, which is 4. And you would graph that, okay? So we would come over here, 1, 2, 1, 2, 1, 2, 3, 4. And I'm going to graph -2 1/4, -1 1/2, 0, 1, 1, 2, and 2, 4. Okay, what is your domain?
Negative
It's
2
all real
infinity.
numbers.
All real numbers.
Oh, wait a minute.
What is your range?
0.
No.
Or it's doing greater
And
than
-2.
What's greater than 0?
Anything greater than
No.
0?
You have to give me a variable that goes with that.
How did you do domain?
If we're looking at the graph, X is 1.
Wow, no.
It's greater than, it starts at 1, right?
Y is greater than or equal.
Y,
greater
no,
than
not equal to.
0.
Y is greater than 0, period. Talia, can you plug anything into an exponent? Any negative or any positive number?
Yeah.
That's how I get my range,
Oh, wait, so
my
you have to
domain.
do
Wait, what does
greater
that say?
than, less than.
What do you mean, what does it say?
All real
numbers.
All real numbers?
Oh, okay.
Yeah, that's all I think about.
Definitely. Okay, let's look at a couple different ones. let's look at this. What does this first one tell me? When it says y equals 1/2 times 4 to the x, what does that half tell me?
It
It's gonna be
will shrink
straight, it's
by,
gonna be short to the,
shrunk by a factor of
It's
half.
gonna be shrunk by what?
a half,
A half.
or two.
It's gonna be shrunk by a unit of 1/2, okay? So, we plug in numbers again. You are going to show me a lot of charts tonight on your homework. If you don't show me charts on your homework or your quiz, you'll get it wrong. Okay, y equals 1/2 times 4 to the negative 2. What do you have to do with that? Flip the 4, so it says 1/2 times 4 squared. What's 4 squared?
16.
And what's 1/16 times 1 second? 1/2.
1/32.
1/32. Okay, then we have y equals
132.
1/2, you say 30 seconds.
Can't move already.
4 to the negative 1, what do I do there?
You flip it.
Flip it.
1/4.
1/2 times 1/4 gives you what?
1/8.
1/8, okay? What happens when I get y equals 1/2 times 4 to the 0? 4 to the 0 is 1, so you get, does that show that it is shrinking by half a unit?
Yeah.
Yes.
Y equals 1/2 times 4 to the first. What's 4 to the first?
4.
And times 1/2?
2.
Okay, and y equals 1/2 times 4 squared. 4 squared is?
16.
And 16 times 1/2?
8.
And I would graph this. Okay, so you graph -2, 1/32, -1, 1/8, 0, 1/2, 1, 2, 2, 8. There's, what's your domain?
All real numbers.
What's your range?
Y is greater than 0.
Y is greater than 0, yes.
Maybe y greater than -1.
Push that
Why is
in.
it, why is it?
No, it's y is greater than
You
0.
can't have a different,
You can, we haven't gotten to that point
I'm
yet.
just saying, it is greater than -1 though.
No, but it won't cross the x-axis, which is why we say y is greater than 0. It's what will it not cross? It will cross 1.
Period.
Not -1,
Not -1, but what will it not cross first? 0.
I'm just saying.
Okay, now we have this. Y equals negative 5 seconds to the x. Okay, notice that that negative is on the outside. What does that negative do?
It brings everything down.
It's gonna be later.
Yeah,
It what?
It's gonna fit down.
Yeah.
It's gonna flip down. So instead of being exponential growth like this, it's gonna be exponential growth into a negative value.
Wouldn't that be?
No, that is not decay.
Okay,
Decay, the graph flips opposite.
so it's going like that. Well, that way, I'm confusing myself.
It's
Going the
going
opposite
down.
way.
How about if we graph it and look at what it's doing? Okay, so now we're gonna have to make a chart, x, y values, right? -2, -1, 0, 1, and 2. Okay, if I plug in a -1, what do I have to, or a -2, what do I have to do?
Put it
Plug it into your calculator.
No. Flip the fraction. So instead of being 5/2, it's gonna be 2 squared over 5 squared.
So
So 2 squared, yeah, so 4 over,
25.
so -4/25, because I have to multiply by this negative on the outside. -4/25. Then you have y equals -5 seconds to the negative-1st. What do I do? Flip it, so that you get 2 to the 1st over 5 to the 1st, so 2/5, so you get -2/5. Then you have y equals -5 seconds to the 0. Anything to the 0 is?
1.
So you get
Negative.
-1, good. Then you get y equals -5 seconds squared, so what do you get? What's up
Negative
top?
5/2.
25 over 4.
25
Wait,
over
wait a minute.
4. So -25/4, which is negative,
No. Nothing,
You skipped
nothing.
one, you skipped one.
oh, I'm sorry, I
That's
skipped
why I
one.
said the.
Olivia was being ahead of schedule. -5 seconds is -2.5, right? Okay, and then when I square it, you get 25 over 4, so -25/4, which is -6 1/4.
What?
Okay, And then I would graph this. -2 and -4/25. -1 and -2/5. 0, -1. 1, -2.5. 2, -6 1/4. Okay, and so my graph looks like this. What's your domain?
all real numbers.
What's your range?
Y is less than 0.
Less than 0. Okay.
Oh, you done? Is that it?
Nope.
We got like 5 slides left.
Oh.
Wait, am I right?
Yep. Y equals 4 times 2 to the x minus 1 minus 3. Now, what's that 4 tell me?
It is going to,
It's gonna stretch.
Stretch by 4 units. What's the -1 and the -3 tell me? Because here's the deal. I guarantee some of you don't know because it tells me the same thing on every graph we've done this
I'm
year.
about to tell you right now, look. The negative
Negative
1
3 moves
is
down.
to subtract it from the exponent, like that you plug in, and then the negative 3, you take
Yeah.
away from the answer.
Okay, Olivia, what's the -3 do?
It moves it down 3 points.
It moves it down 3 units. What does the -1 that do then?
It moves it.
up.
No.
It moves it down.
Was it
When
right?
it is with,
Like
it
this.
moves, when it is with the x, it moves it to the right or left. So does it move it to the right or left?
Left.
No.
Right.
It moves it to the right because it's always opposite. When it is with the x, it is always opposite. Because it would be like saying x minus 1 equals 0 and you solve for x, you get 1. You always have to think opposite. You guys keep messing that up. You have to understand that does not change on any of the graphs that we do. It's the same rules. The y, what's on the outside, moves it up or down. Whatever's with the x moves it left or right, and it's opposite. Now, when you go to graph this, you are going to graph it the way I want you to. And there's a reason for it later on. What?
So it's starting at 1 negative.
Yeah. So, well, it shifts 1 -3 units. So if my parent function is here, it would shift 1 unit over 3 units down, every point on that graph. Okay? Now, we are going to graph this not by plugging numbers into that and doing the whole equation. We're only going to focus on this portion of the equation, and then we are going to shift it. Okay? If you don't do it this way, when we get to logarithmic functions
What is that?
and natural log functions in
One
graphing,
step at a time.
you're gonna mess it up. So we're going to shift, we're gonna graph and then shift, so that when we get to those, we know how to do that process already, it makes it easier, okay? Mr. Rice wants it graphed it and then shifted, okay?
Please
So
don't
we're-
even tell us about the future, just let's get through this.
So we're gonna make a table again, and we're gonna plug in -2, -1, 0, 1, and 2. We're gonna focus just on this part. 4 times 2 to the -2. What happens here?
Flip.
Flip. So you get 4 times 1 over 2 squared. You get 4 times a fourth. And what's 4 times a fourth?
1.
1. Okay? Then we're gonna come down here and we're gonna say 4 times 2 to the -1st. You
Flip it.
flip it. So I get 4 times a half, which is? Then I have y equals 4 times 2 to the 0. So I get 4, good. Then I have y equals 4 times 2 to the 1st, which I get 8, good. And then I have y equals 4 times 2 squared. 2 squared is 4, and 4 times 4 is. Now we're going to graph what we have here, and I'm going to count by 2's on my y-axis. 2, 4, 6, 8, 10, 12, 14, 16, 18.
Wait, why?
Because I have 16.
Alright,
You can count by different things. It's okay. You can count by different things.
I'm just saying.
So if I have a -2, I have a 1, okay? If I have a -1, I have a 2. If I have a 0, I have a 4, a 1, an 8, and a 2, a 16. Okay? There's this graph. Now, we need to shift it.
I'm confused.
You are adding 1 to the x, you are subtracting 3 from the y, yes?
Mhm.
Okay. So what does this new point become? If I add 1 to negative 2, I get,
-1,
and what's negative 3 and 1 together?
-2.
Okay. So negative 1, negative 2. Negative 1. Oh, I need to put.
So you
do
so you
you
draw
put
the graph
both
first
graphs
and
on
then you
that?
shift it.
Yes.
Okay.
You draw it first and then you shift it. So I'm gonna go to negative 1, negative 2. So negative 1, negative 2. Okay? That shifted it over 1 unit this way and down 3 units, yes? Because it was at 1,
Yeah.
0, negative 1, negative 2. Okay? What happens here? When I add 1 to this, you get,
No, you said try. Oh,
one.
yeah, I want it, and then you get 0.
When you add negative 3 to this, you get negative 1. So 0, negative 1. Okay? Add 1 here, you get 1. Subtract 3 from here, you get 1. So 1, 1. Add 1 here, you get 2. Subtract 3 from here, you get,
5,
so 2, 5. Add 1 here, you get,
3,
subtract 3 here, you get,
13.
13.
so
Oh, that's my
3,
number.
13. Now, there's this. What's your domain? All real numbers. What's your range?
Would that be, greater than -3?
Yes, y is greater than negative 3. Your range always comes from what's being added or subtracted from out there.
Okay.
Okay? Y is greater than negative 3 is my range. Okay? So that's the trickiest type. Graph it with the simplest form and then shift it for me. So you can use different colors if you need to.
Is it always gonna be all real numbers for doing?
On, yes. Okay, the last couple things we need to talk about is stuff that you talked about in 8th grade, because I just taught my 8th graders this like a week ago. Exponential growth models. You remember the model like A equals P times 1 plus R to the T power, where R is your rate, T is your time,
Yeah.
P is your initial amount.
No, ma'am.
Okay, exponential growth. This comes in handy when you are dealing with loans. Or the bank, okay?
Yeah.
So we're first gonna look at exponential growth with the formula y equals A times 1 plus R to the T.
R is the rate.
R is your rate and it has to be in decimal form.
Always.
T is your time in years. So if it says 6 months, you have to put 1/2 up there, or 0.5, yes, okay?
All in
A is what you start with,
I
okay?
do remember this a little bit. Y'all remember this?
Yeah.
So, we're gonna do part of this and then I'm gonna explain, how, on some of your homework, I think I picked out the right problems, but on some of your homework, if it gets to a point where you can't graph it because you don't have a graphing calculator and it's too big of numbers by hand, just stop.
Did you say poems?
Homework.
Dude, you tripping.
If you have too many problems in this class, I'm dropping out.
In 1996, there were 2,573 computer viruses and other computer security incidents. During the next 7 years, the number of incidents increased by about 92% each year. Well, think about how much bigger the web got, like,
Still that.
and how many more people had computers,
That's a lot.
right?
Still.
Think
Write an
about it.
exponential growth model.
If you think about it, the virus only came from people who were malicious with their computers.
Okay,
That's
write an exponential growth model giving the number in of incidents T years after 1996. About how many incidents were there in 2003? So first we need a model. What do we know to plug into this model they gave us?
the time.
Every.
You can start with
Yeah,
years.
you know the time, well, you know the
There's
time,
92%.
but 92%, turn 92% into what?
We gotta find A.
0.92, okay? We'll talk about T in a minute. What's your A? 2573. Okay, so here's what, this is the equation they want, yes?
Yes.
It says, about how many incidents were there in 2007? Or 2003? What's my time?
That would be.
7 years.
Wait.
It's you can add it in your head or you can read the problem because it says the next 7 years.
Oh, okay.
Okay. So then I saw from here, what do you get when you plug that into your calculator?
I got you.
No, you're pretty sure.
2, 5.
You just have that five.
That's a big number.
There's 2, 4, 7, 8.
It should be,
2, 4, 7, 4, 8, 4.7, 9.
okay, so we're gonna round it to 5. Okay, 247,485 incidents in 2003 roughly. Okay, now it says graph the model. This is where I'm telling you, you're not gonna be able to graph this right because you don't have a graphing calculator, okay? But what you will be able to do is, can I plug numbers into T?
Yeah,
Yes, can I get outputs?
yeah,
So you can make an input-output chart for me?
yeah.
And then you can roughly make a sketch of if that's increasing up or if it's increasing down, okay? Yes, Devin?
So let me guess. Y is gonna be what you get out for X, which is your T.
Correct.
Hmm.
Okay, now, if I had a graphing utility, it's really cool because it keeps the data inside there, and I can go to where 125,000 is for Y, and I can tell you what time that was, how many years that was.
Wait, what?
Now, how could I work that if I can't use a graphing calculator?
Well, you can put in Y,
You
go ahead.
could divide by the number.
No.
Set,
No, you do it too
set
difficult. You beat it
1,000.
No, 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 no.
You just put in 125 and you find T,
Okay, yeah, you'd put 125 into Y. The problem is T is in what place?
exponent.
Do we know how to solve that yet?
No, but you can teach us.
No, but we'll learn. We're not gonna worry about that now, but we'll learn in a couple lessons how to solve that using logarithmic
I mean,
functions.
tomorrow. Couple lessons.
The last thing we need to talk about is compound interest. This is your friend if you are earning money off of it. It is not your friend if you're paying compound interest. Compound interest says A equals P times 1 plus R over N to the NT power. What do you think R stands for?
Rate.
What does N stand for?
Number.
Number of what?
Do we have to know these
No,
formulas?
Yes.
times per year.
Yes, how many times per year? So if they say quarterly, it's,
4.
if they say monthly, it's,
12.
get it, okay.
That don't make no sense.
And then T is your time in years again, okay?
Always time
So
to
let's
use.
take a look at a problem of that and then we will get busy. You deposit $4,000 in an account that pays 2.92% annual interest. Find the balance after 1 year if the interest is compounded. See, that's how I know to use this formula. It says compounded. You only use a compound formula when it says compounded,
So it always tells you.
okay? Which is why you should never miss that. Use some
At the
common
same
sense.
time,
So we.
Okay, so when it's compounded with a given frequency. First one it wants quarterly. How do I solve that?
Well,
You have to plug in.
Since quarterly is 4, you know.
A equals what? What's our initial amount?
2,000.
4,000?
1 plus.
1 plus, what's my rate?
0.0292.
0.0292 over what?
4.
Because it's quarterly. And then it's 4 times what? Top. How many years are we looking at?
1.
Just 1, okay? So then I plug this into my calculator. I suggest doing 0.0292 divided by 4 first, so that you get 1.0073. It makes it easier. You won't mess up as much. And then you're raising it to the 4th, right? And then you're multiplying it by 4,000. And you get $4,118.09. That's when you're doing it quarterly. So if you're just getting an investment off of this compounded quarterly, no, in 1 year you made $118.09 and you did nothing.
That sucks.
Okay? Now B says what? Daily?
I haven't looked at 2 months.
Okay? Daily. So we use the same formula except instead of 4 we say what?
4.
Oh,
365.
365.
Unless it's leap year.
Oh, because it's per day.
I thought we used 366.
Just, no, always use, they always make you use 365 in math just
But
because
really-
that's more of a year than you know.
But if you think about it, a year is actually 365 days and a quarter.
How?
Thank
That's
you.
why there's a leap year.
Yeah. Sorry, calendars.
0.0292 divided by 365. Well, we'll do that. So I want to multiply this together, right? So I'm gonna do 4,000 parentheses 1 plus parentheses 0.0292 divided by 365 in parentheses, double parentheses, to the 4 times 365, and you should get $4,495.56. So you made $495.56 when it compounds daily. Is that a big difference
Yes.
in quarterly? Yes. So in 1 year, if I'm compounding daily, I can make almost $500. But if I'm only compounding quarterly, I only make $118.
Why did you force it?
And your stuff has been in that, your money has been in that account for the same amount of time, yes? 1 year.
Is that 400 or 4,000?
Oh, this should be, maybe I'm wrong. I
Hey,
know.
Doug, is that you making all that noise?
This should be 1.
Mm-hmm.
I'm being stupid. It's not gonna be that much of a difference,
Right.
because it's 4 times 1, not 365, right? Times T,
Yeah.
my bad.
That is gonna make a
That
difference.
does change the.
It does change it, but it's still gonna be more because it's
Big one.
daily. It's just not gonna be significantly more, just so you know. It's gonna only be, I must plug this in there, all right?
Miss Peter.
What?
What's going on?
I'm having, I'm being a moron with my calculator is what I'm doing. It should be 118, like 50 something, I think. So really, it's not that much more in this case. But it could be over time. Those are the things you're working on. Everything is plugging and
Can I
chugging
take a
stuff
picture?
in.